Hey everyone, welcome back to the channel. If you love those mind-blowing cosmic mysteries, today's What If is going to hit hard. We're talking about fast radio bursts, FRBs, those ultra-short, insanely powerful flashes of radio waves from deep space that last just milliseconds but release as much energy as the sun does in days or weeks. Thousands have been detected, some repeating from the same spot, others one-offs from halfway across the universe. For years, astronomers have debated what causes them. Neutron stars, black holes, cosmic strings, alien tech? Okay, probably not the last one. But right now in 2026, the strongest evidence points to one culprit: magnetars. So, let's break it down. What is a magnetar? It's a special kind of neutron star, the super-dense core left after a massive star explodes in a supernova. Normal neutron stars are already extreme, 10 to 20 kilometers wide, but heavier than our sun, spinning fast with magnetic fields a trillion times stronger than Earth's. Magnetars crank that up even more. Magnetic fields up to 100 trillion times Earth's. That's 1015 Gauss. Their crust can crack like an earthquake, releasing huge bursts of energy in X-rays and gamma rays. But could that same energy also blast out radio waves as FRBs? The connection started getting serious in 2020 when a magnetar in our own galaxy, SGR 1935 plus 254, produced a bright radio burst that looked exactly like a fast radio burst, the first time we saw one from a known object. That was huge. Fast forward to 2026, and the evidence keeps piling up. In March 2026, astronomers announced the first direct observation of a magnetar's birth inside a superluminous supernova, a super bright exploding star. Data from SN 2024 FAV showed a chirp in the light curve, explained by a wobbling accretion disk around a newborn magnetar with a 4.2 millisecond spin and insane 1014 Gauss field, perfect conditions to produce FRBs. This confirms magnetars form with the exact spin and magnetism needed to power those bursts. Other recent finds strengthen the link. In January 2026, a repeating FRB showed diverse activity hinting at a magnetar in a dynamic plasma environment. Another study found evidence that some repeating FRBs come from magnetars in binary systems, orbiting a companion star, where interactions create the right setup for frequent bursts. MIT's work penned a 2022 FRB to a magnetar's magnetosphere, the highly magnetic zone around the star where twisted fields release radio waves. And observations show FRBs often come from massive star-forming galaxies, exactly where young magnetars should form after supernovae. But not all FRBs fit perfectly. Some come from old, quiet elliptical galaxies with no recent star formation. How could a young magnetar be there? Maybe older magnetars survive longer than we think, or different mechanisms are at play for non-repeating ones. Still, the leading theory in 2026 is that magnetars are the main engine for most, if not all, FRBs, with starquakes, magnetic reconnections, or binary interactions triggering the blasts. So here's the big what if. What if magnetars really are the power source behind these cosmic fireworks? These ultramagnetic neutron stars, born in explosions, could be firing radio beams across the universe like natural lasers. If true, every FRB we detect is a message from one of these extreme objects, telling us about neutron star interiors, magnetic fields stronger than anything on Earth, and the violent deaths of massive stars. What do you think? Are magnetars the answer to FRBs, or is there something even wilder out there? Drop your thoughts in the comments. Repeating bursts from binaries, one-offs from something else. I'll heart the best ones. If you enjoyed this deep dive into fast radio bursts and magnetars, smash that like button, subscribe, and hit the bell for more what-if space mysteries every day. Thanks for watching. See you in the next cosmic puzzle. Aye.